Good morning and good afternoon, and welcome to this next lesson about, well, if you're in my classroom, the matters of STEM, or what is STEM. Alrighty, so in this area, we're going to obviously explore potential careers within STEM, where physical sciences may take you. Now, here's the thing, okay? You're probably thinking, Mr. Cadle, why are we learning about careers in STEM? Shouldn't we be focused on things like robots or what you talked about with your last lesson, science and the integration of technology and the integration of engineering and the integration of math? Well, yeah, but here's a good thing, okay? STEM is part of the CTE program here at RSG. That's Career Tech Education. And obviously, that's careers. Careers have to do with our future jobs and the path that our future jobs might take us in. And it's not always a straight line. There might be some deviations. I'll give you a little hint. When I graduated college, I didn't think I'd be a teacher. Sure enough, here we are in the classroom. So let's go ahead and move forward. All right, so here we have some objectives line out. What we're going to look at is we're going to discover how STEM can shape potential career pathways and educational journeys. Alrighty, we're going to look specifically at those STEM careers dealing with the physical sciences, not necessarily environmental sciences, which we learned that we could also learn about, but we're learning and focusing on physical science. And we're also going to connect the ideas that focus in STEM, again, the integration of science, technology, engineering, math, into the real world. In other words, the things that happen after high school, or the things that might happen after college, etc. And I understand we're in the 6th grade, we're a little bit of a way, but maybe it's a good idea to start thinking, what do I want to do when I graduate? And we're also looking at various career fields as well. So you got careers and career fields. Example, in the medical career, you have doctors, right? But you have various areas of doctors that you might work in. Do you want to be a brain guy? Do you want to be a heart guy? A lung guy? All right. Do you want to be a bone guy or a foot guy? Right? I say guy, doctor, or lady. You get the idea, right? So those are things to think about. Okay. So you probably heard this before, and you probably drew pictures back in elementary school. What do you want to be when you grow up? Now, you're probably already maybe answering that in your mind, and that's cool. But again, that might be subject to change. So let's look at a few things that connect with STEM, all right? How might your career choice change or involve STEM, okay? If you really like the things that you're finding and discovering, you really find that you're understanding the mechanical side and the engineering side, well, fantastic. If you're understanding the tech side and the programming and the coding side, well, fantastic. How might that evolve over the years? And speaking of coding, those have undergone serious changes in the last few years with the new, well, not say new, by using GPT models and now computers and programs that can program themselves. That is huge. That is a huge concept and a very big change over the last several years. What concepts from STEM might be important, and what problems could STEM help solve within your career choice? All right, so we're going to focus on STEMs that might be, well, unexpected, okay? Example, some of you might be thinking, I want to be a video game designer. Well, that's great. Well, if you're going to be a video game designer, think about motion, right? The simple motion of, say, something on what they call a fulcrum, right? Or a little pivot. Look at the motion there. How does that move? How does that work? Maybe you're designing a game that focuses on collisions. You want to have more lifelike collisions. Well, what really happens in collisions? What are the forces and the energy at play? How does gravity affect things? In other words, how two things are kind of attracted to each other and kind of pull things towards each other, right? You also got sports coaches because you're thinking about maybe forces and energy, especially we're in the fall, right? So we're thinking football maybe. How do pads help distribute the energy during a collision? Or how does the collision on the top of the head, what can be done to help prevent maybe something medically going on in our noodles, right? So maybe those are unexpected. You got chefs and food scientists. You're thinking about heat transfer, the chemical change of matter, right? How does something differ from cooking it one way as opposed to cooking it another way or preparing it another way, right? How do the different flavors and chemical compounds work with each other? Acids, bases, salts, proteins, etc. Or if you're in the musician world, you're thinking maybe about sound waves and vibrations and acoustics. How do sound waves work inside of an enclosure, and how are they distributed out? What makes the cars go boom, if you know what I mean, all right? And then, of course, maybe you're thinking about doctors with maybe radiation, electricity, and pressure, and, of course, all the biomechanical things that are going on, and maybe architects that are focused on forces and structures and materials. There are a lot of careers out there that use STEM. However, we're going to focus on 3 exciting careers that utilize the physical sciences. And I'll give you a little clue. There's a hint there, and a hint there. Let's go ahead and dive a little bit deeper. All right, let's take a look at aerospace engineering. Now, Mr. Cato loved the aerospace, especially in the 90s. In the early 90s when he was growing up, because we were going through what was the Gulf War, okay? And I was fascinated by the airplanes, the satellites, and putting things up into space and what have you. That always interested me. And that was right when I was in your guys' age, right around in middle school. And so although aerospace engineering wasn't one of my things, I had a lot of designs in mind that eventually I even kind of saw implemented as time went forward. Like the modern, the F-22 Raptor? I kind of envisioned what used to be an F-14 Eagle with all those fancy shapes. And if you don't know what I'm talking about, after this video is over, Google Eagle, F-14 Eagle, and F-22 Raptor, and see how their shapes are similar, but the Raptor is more stealthy and such, right? So with aerospace engineering, discover how forces at play affect aircraft design. This might include things like, typo there, lift, drag, thrust, and weight. Notice how forces at play is important, right? I'm going to focus on it just for a second, right? The forces at play are what we talked about last lesson with the laws of nature. Is something affecting something else, all right? Such as wind resistance or some kind of resistance, gravitational pull, weight, right? What are the forces at play? For every action, there's an equal and opposite reaction, right? How do those airplanes stay in the air and seem to maintain their flight, okay? Those are the forces at play, okay? You got this, when you're in aerospace engineering, you're studying forces, motion, energy, and of course, aircraft design. And of course, aerospace engineers think about projects like the Mars rover and the rover design, right? That was a huge monument, right, of scientific discovery, sending a little robot off to a foreign planet to kind of dig things around and look for life and get some pictures and to see what things are really happening over there. And it was a success. Even though the robot for the most part isn't working anymore, it still was a huge, huge success for discovery, right? It helped further our human understanding. These projects use advanced physics principles, okay? Advanced calculations. It took a lot of thought, a lot of human intuition as well, right? So what do they do? Well, these engineers think about satellites and spacecraft and even missiles, right? Even like, things that you put on top of missiles and the flight and maintaining the flight and getting onto their target. Test flight systems to help improve performance, or maybe they even help solve problems related to space travel. Those are the guys who are thinking, how are we going to get to the moon and stay there? How can we do it safely? Once we're in the moon, how are we going to set up a base so that we can go further than that, right? They're the ones that are trying to figure out, is there a way to travel almost the speed of light, if not as fast as, if that's even possible, right? You got daily physics applications that they deal with, such as forces, calculating lift, drag, thrust, weight. I keep on saying that, right? Motion, flight paths, trajectories, things like that, okay? And then how are we going to make sure that we have enough fuel to make things happen? Here's a little cool fact. They use the same physics principles or principles in physics that we will learn with paper airplanes. All right, it says we will have learned, we're going to learn about that. All right, same concepts though apply. How about robotics engineering? While we may not be studying robots directly, okay, it takes a lot of study, a lot of integration of STEM to make that happen, right? Robotics engineers create innovative designs. That's important. Innovation, right? Innovations means having something that's old and changing it and making it new and better. You're innovating. Using mechanics, electricity, and force, right? You got to understand all those to understand how the robotic systems work. You've got to understand how much force is applied. You don't want just the wombat to swing its arm and then, its arm fly off or hit something and it tears it apart, okay? Maybe you want to move something and move it gently. How are you going to make the robot do that, right? So it takes a lot of understanding of different forces and applications, right? And of course, mechanics, how things move. It's not just gears, right? But how do things move? Maybe hydraulic, electrically, or electromechanically, or electromagnetically. There's a whole bunch of ways to get things to move, right? Robotics engineers think about maybe robots in the medical field that help with surgeries, or robots and designs that can help navigate, such as the rover itself that went to Mars we just got finished speaking about. Or maybe, how Tesla has designed their little robots that are helping people live and do things as well, right? So what do? They build robots for various applications. They program movements and responses and test robotic systems. They're understanding mechanics on using gears and levers and electricity and understanding forces like grip strength, things that we just talked about a few minutes ago. How about this? Robot movements follow the same physical ideas as human robots if they're designed to look like us, right? If they're not, well, there's some slight changes and things, but overall, they want them to try to be more humanoid depending on the application, right? And then, of course, you got materials specialists. Materials specialists are really good because they're awesome because they're trying to figure out the unique compounds that they can make things with, right? The material properties, all right? Take this thing, for example, all right? This thing has Gorilla Glass on that. That was a new material up to a few years ago. It was strong, it was intense, and allows you to still touch and type on this thing, right? For the most part, and do things and interact with the phone, right? That was a new material. Okay, they're trying to impact technology in our everyday lives through changing matter, and they have to understand how matters and materials works. And then, of course, you got to understand the various energies at play, right? What about the energies at play at, say, like a Kevlar, right? Because like you have a Kevlar vest or a bulletproof vest. What is really going on there? What are the energies at play on that vest, right? They protect our officers when they're out and about, and our police and our military. Okay, very important to make sure that they're protected. How do they make sure it helps them against projectiles, right? Material specialists, again, help develop innovative products like the smart screen, as I just showed you, or even athletic gear. Okay, not necessarily with the way that they're designed, but the materials themselves at play. Okay, is it a breathable fabric? Is there something new they could put in the helmets that might help absorb some of that energy to help, again, with damaging our noodles? You get the idea there. So they study properties on different materials, they develop new materials for specific applications, and they test how these materials operate. They need to understand the properties of matter and chemistry and density and maybe even electric conductivity. They understand or need to understand how they absorb and reflect and conduct, right? And that could be anything from light to heat to energy that they dissipate, okay? It's not like they're out there being Black Panther absorbing energy and dispensing it on their own, okay? That's something from the comic books. But can it really happen? Is there a material that can make that happen? That's up for the material scientists to figure that out. And of course, you have phase changes, studying how things change from solid to liquid to gas, right? They basically create materials stronger than steel, but can make them lighter than water. Kind of like Kevlar or carbon fiber, right? Really neat stuff. So that brings us to the end of this presentation. And if you're in Mr. C's class, I believe there's a little career research activity that he will walk you through All right, I hope you got something from this brief presentation. Thank you for watching.